Hi everyone. We're going to be looking at another topic in mathematics, which is numbers and language. And we have our slide here that will serve as a guide for this class. Now, when we're talking about natural numbers, what are natural numbers? Natural numbers are counting integers which does not include zero, but start with one and end with infinity. So when you're talking about natural numbers have no end. It has no end. And it continues. You can have it in 10,000, we can have it in 100,000, we can have it in a million, we can read in a billion, and like that, it goes on and on and on. So when you're talking about natural numbers, zero is not included, and we can read as higher as possible. Now we have an example here. Let's just list examples of natural number. We started with 1, 2, 3, 4. Why is zero not inclusive? Because zero is not a natural number. So let's look at the activity we have here. After 4, what else can we have? We can have 5, right? After 5, what else can we have? We can have 6, we can have 7. But zero cannot be inclusive, and minus 4 cannot be inclusive in natural number. So let's check our answer. Yes, we are right. Now let's see what we have. We have integers. Integers are numbers that can be either positive or negative or zero, but cannot be a fraction or a decimal. So when you're talking about integers, they are numbers that can not be decimal points, it cannot be in fraction, but we can have it as a zero, we can have it in a negative natural number, we can have a positive number. So we have example here. Example of integers that we have listed here is what? Minus 4, minus 3, minus 2, 1, minus 2. Now from here, let's highlight the positive aspect of the natural numbers that we are talking about that contains an integer. So another example is that since our integers are numbers that are what that can have zero, so zero is an integer, then 1 is an integer, then 2 is an integer. 0.334 and 0.098 is not an integer because based on the definition, it doesn't contain a fraction or a decimal. So let's check. Okay, now we are cool. Now let's look at another one we have here, which is rational numbers. What are rational numbers? Rational numbers are numbers that can be expressed as fraction, which can take this form. We have a over b, where our a is what? Our a is our numerator and our b is our denominator. Where a and b are non-zero, that is, a and b cannot take a zero value. So example of rational numbers are 2 over 3. Since they said that it can be expressed in fraction, then we have 2 over 3, then we have 3 over 11 and 21 over 70. Minus 1 over 2 is not a rational number because it cannot take a negative form of fraction, and 0 is not a rational number. So let's check. 0 is not a rational number. So let's check what we have. Okay, yes. Now let's look at irrational number. Irrational numbers are numbers that cannot be expressed as a ratio or a fraction, but can be expressed as a decimal and square root. So one thing about irrational number is it cannot be expressed in the ratio, it cannot be expressed in fraction, but it can be expressed in decimals. So we can have our decimal points and we can have our square root. Example of irrational numbers are we have root 2. Now from this exercise, let's look at other example of irrational numbers that we can pick from here. So I think we can pick root 7 as well. We can pick 0.1238 and we can pick 3.8888. But we can't have 2 over 7 because 2 over 7 is what? Is a fraction. So let's check if we are right. Wow, we are cool. Now let's look at the topic again that we have under numbers and language, which is real numbers. So when you're talking about real numbers, it consists the set of what? Of both rational numbers and irrational numbers. So when you have a real numbers, it comprises of both rational numbers and irrational numbers. So when you have a fraction, you have a square root, you have a decimal point, we have a decimal values, and we have a root number. Then we refer to such type of numbers as what? As real numbers. And we have example here: 2 over 3, 3 over 11, 21 over 70, root 2, 0.1238, root 7, and 3.8. It goes like that. So these are just examples of our rational and irrational numbers, and this comprises of what? Real numbers. Now this leads us to the next slide that we have. What are prime numbers? Prime numbers are natural numbers that are greater than 1 and has only two factors, which is 1 and the number itself. So when you are talking about prime numbers, any number that can divide itself and 1 alone are prime numbers. So we have example here. Example of prime number: 2, 3, 5, 7, 11, 13, and 11, 2, and 17. If you look at these numbers, the divisible values are just 1 and the number itself. So the factor for this number are 1 and 2. We have 1 and 3, 1 and 5, 1 and 7, 1 and 11, 1 and 13, and 1 and 17. So now let's look at the examples of prime numbers that we have here. So what are examples of prime numbers? Let's look at this. We have made mention of 2. Then we can have 13 also as prime number. We can have 7 also as prime number. We can have 13 as prime numbers. Because if you look at 3, the only value that can divide 3 is what? 1 and 3. If you look at 13, the only value that can divide 13 is 1 and 13. And if you look at 7, the only value that can divide 7 is 1 and 7. So let's check. We are right. Now that leads us to the next subtopic, which is reciprocal of a number. The reciprocal of a number is obtained when 1 is divided by that number. So when you have any given number, you divide 1 by it gives us reciprocal of that number. Now we have an example here. So we have the reciprocal of 8 is what? 1 over 8. Because by the time you multiply or divide 1 by 8, it will give us 1 over 8. Now the reciprocal of 3 over 5 is what? Is 1 divided by 3 over 5, which is what? Which is simply 5 over 3. So I want us to express this quickly and let's see how we can go about it. Okay, so now let's have that. The reciprocal of, want to see the reciprocal of what? Of 3 over 5. So let's divide the 1 by 3 over 5. So it's going to be 1 divided by 3 over 5. So by the time you are changing this, the numerator becomes the denominator and 3 becomes the denominator. So 5 comes up, 3 comes down. And this sign changes from division to multiplication. So we can now have it to be what? 1 multiplied by 5 over 3. What is 1 times 5? That is 5. And we have over 3. So the reciprocal of 3 over 5 is going to give us what? It's going to give us 5 over 3. This leads us to the next slide, which is factors and multiple. Factor is a number that is divided by another number evenly without remainder. So when you divide a number with another number and it doesn't have any remainder, and it goes without remaining any value, then we refer to such a number as a factor. And we have examples of factors that we have. The example of factor that is listed there is, let's assume that we have 12 and we want to get the number, the factors of 12. So what we look at is what are the values that actually goes in 12 and it will not remain. So if 12 divided by 1 will give us what? Will give us 12. So 1 is actually a factor of 12. And let's look at the other numbers as well that are factors of 12. Okay, quickly we are going to be doing that. So let's pick 12. We said 12 divided by 1 will give us what? 12. That's that. Now let's go and look at 12 divided by 2 as well. 12 divided by 2 will give us what? That will give us 6. So it is not remaining anything. So 2 is actually a factor of 12. Now let's look at another one. Let's try 12 divided by 3. 12 divided by 3 will give us 4. So 3 is also a factor of 12. 12 divided by 4 will give us what? Will give us 3. So 4 is a factor of 12. Let's try 12 divided by 5. 12 divided by 5, what is it? 12 divided by 5, that is 2. It will remain what? It remains 2. So 5 is not a factor of 12. Another factor of 12 that we can look at is 12 divided by 6. 12 divided by 6 will give us 2. So 6 is actually a factor of 12. So we have 1, 2, 3, 4, and 6 as factors of 12. Now, when you are talking about multiples of a number, it's a number of products that can be divided if two numbers are multiplied. So if you have two numbers multiplied together, the product that value is given will be given to us is what we call multiple. Now, if you are looking for multiple of 5, then that implies that you are going to be looking at what you can multiply with 5, with 3 rather, and to give us exact number. So let's look at it. If you have 3 multiplied by 1, 3 multiplied by 1 will give us what? 3. So a multiple of 3. We have 1. So let's see. We have 3 multiplied by 2. So 3 can actually multiply 2 to give us another value, which is 6. So another multiple that we can have is what? 3 multiplied by 3. What is 3 multiplied by 3? 3 multiplied by 3 will give us 9. So those are examples of multiple values. So with this, we are going to be looking at other examples we can derive by multiplying 3 with any other value. We have already listed some here, which is 3, 6, 9, 12, and 15. So how did we get 3? So 3 times 1 will give us what? 3. Now how do we come about 6? That is what? 3 times 2, which is 6. How do you get 9? That is 3 times 3 will give us what? Will give us 9. So let's see what the next values is going to give to us. So now when we have 3 multiplied by 4, what will 3 multiplied by 4 give to us? That is going to give us 12. So we have 3 multiplied by 4 here. Now let's look at what else we can multiply with. If we have 3 multiplied by 5, it's going to give us what? It's going to give us 15, right? So 3 multiplied by 2 will give us what? 3 multiplied by 2 will give us 6. So we can have this as well. Now 3 multiplied by 3 will give us what? 3 multiplied by 3 will give us 9. So we can have this as well. So those are the listed values for the examples of multiples of 3 that we have there. So let's check and let's see. Okay, now let's look at the next slide, which is what? Which are prime factors. As we have said earlier, that prime numbers are what? Number that can divide one and itself. So what are prime factors? Is any prime number that can be multiplied to give the original number. So when you are talking about prime factors, when you have numbers, you multiply them together, that is prime numbers that can multiply together to give original number. They will refer to that as prime factor. So we have an example here, that what are the prime factors of 27? What can you multiply? Two numbers that you can multiply together that will give us 27. What are those values? So that should be what? 3 times what? 3 times 3 times 9, right? By the time you multiply 3 by 9 to give us 27. So the prime factors of 27 is going to give us 3, and we have 9. So we have 9. Let's look at the next exercise. The prime factors of 35 are what? That should be 5 times 7. By the time you multiply 5 and 7 together, it will give us 35. So prime numbers of 35 are 5, and we have 7. So let's check if we are right here. Okay, so that leads us to the next slide there, which is highest and lowest common multiple. So we have made mentions of factors, we have made mention of multiple earlier on. So we want to look at the highest common multiple factor and lowest common multiples. Now, highest common multiple or highest common factor of 2 or more numbers is the highest factors of the numbers among all the common factors of a given number. So if you have a given number, you look for their common factors. The highest common factor within the 2 or 3 given numbers is what we refer to as HCF, which is highest common factor. Now, when you're talking about common multiples, when you have 2 numbers, the lowest multiple of those numbers among the common factors of that given number is what we call lowest common multiple. So when you have 2 or more numbers, you find their common, you find their factors of the first number, find the factors of the second number. Now, the lowest common factors between that numbers or multiple between that number is what we call lowest common multiple, and we can easily refer to it as what? LCM. So let's look at what we have here. If you look at this, we have a worked example here, which is showing us that we should find the highest factor of 60 and 72. So we are going to be using this method. Now let's look at this. We want to express it in factors. So if you multiply 2 times 2 times 3 times 5, it will give us 60. If you multiply 2 times 2 times 2 times 3 times 3, it will give us 72. Now let's look at the common factors we have here. Under 60 we have 2, under 72, so we pick it out. Under 60 we have 2 again and another 2, so we bring that out. And if you look at it, we don't have any common multiple here, which is, but if we look at this, we have a common multiple of 3, then we bring them out. Now by the time you multiply the 3 of them together, that is 12. 2 times 2 times 3 will give us 12. So 12 is the highest common factor for 60 and 72. Now let's look at the lowest common multiple of the same value. As we have highlighted the 2 times 2 times 3 times 5 will give us 60. 2 times 3 times 2 times 3 times 3 will give us 72. Now for this place, we have to look at the lowest common multiples. After we have done identifying, you see we have 2 common here, we have common value here, which is 2, another common value here, which is 2. So we bring them together. We have 12, which is 2 times 2, which 2 times 2 is what? 4, right? 4 times 3 is what? That is 12. So 12 now, if you look at it, after that, there's still a common factor here, which is what? Which is 5. So we bring it out. If you look at another value that we have here, what is the common factor in 72 that we have left? That is 2 times 3. So we bring it out. So 12 times 2 times 3 times 5 will give us what? 360. And that is the lowest common factor for 60 and 72. This is a first method. We are going to be looking at another method which is actually very simple for us to do in the next few slides. Now, we have a past question here. This one is telling us that we should highlight the 6 factors of 28. So what are the values that you think that by the time you divide by 28 will be divided evenly without remainder? So we are going to be trying that out, and let's see what are those values that by the time you divide with 28 will give us a value without remainder. So let's start with 1. We have 28 divided by 1. What is that? We have 28 as our final answer. So 1 is actually a factor of what? 28. Let's start with 2. 28 divided by 2. Let's see. Divided by 2. I believe 2 can go in 8. How many times? 4, right? 2 can go into that many times? 1. So 2 is a factor of 28 as well. Now let's look at another one that we have here. 28 divided by 3. Let's try it and see if it's going to remain or not. 3 can go in 8 how many times? That is how many times? That is 3 cannot even go in 2. So that implies that 3 is not a factor of what? It's not a factor of 28. But let's look at 28 divided by 4. 28 divided by 4. How many times can 4 goes in 28? That is 7. So 4 is also a factor of what? Of 28. So therefore, that implies that 28 divided by 7 will give us what? 4, right? So with this, we can now highlight the 6 factors of 28. The 6 factors of 28 that we have shown here is what? We have 1, we have 2, 3 is not going there. So 3 is not a factor. We have 4. After 4, we have, what next do you think we have? We have, after 4, what do we have? We have 7, right? 7, right? So since, look at this. 2 divided by 28 will give us 14. So definitely 14 divided by 28 will give us 2. So 14 is also a factor, and also 28 is a factor because 28 divided by 1 will give us 28. So those are the factors of 28 that has been highlighted. Okay, this leads us to the next slide. Let's look at what we have here. This is a past question. We determine things of 2 whole numbers. Both numbers are greater than 6. The lowest common multiple of the 2 numbers is 90, and the highest common factor of that 2 number is 6. So we have to look for the 2 numbers. So shortly we are going to be solving this together, and we are going to be getting our answer out. But before you, let's just look at it. This is just like a word problem, so you need to think. Okay, now let's think about the number and let's solve together. So now, first and foremost, that implies that if we are looking for the number is actually greater than 6. So 6 is not inclusive. And since we are talking about common multiples and factors, so that implies that we need to identify factors that are more than 6, and which is inclusive. 6 is inclusive. So we have to look for the factors or multiples of values that are greater than 6. So let's look at that. Let's assume that the 2 numbers that we are looking for is x and y. So we denote the 2 numbers as what? X and y. Now, since they said the number is greater than 6, so if we are finding the multiples of 6, then we are not going to be bringing in 6 as a starting point, though 6 is actually a multiple of 6 because 6 times 1 will give us 6. But since this number is greater than 6, so 6 is not going to be in the picture. So the next multiple of 6 that we can have is 12. So another multiple of 6 that we can have is what? 12. That is 6 times 2 will give us 12. Then I think the next one should give us 18. 6 times 3 will give us 18. After 18, what else? What is 6 times 4? 6 times 4 will give us 24. 6 times 5 is what? 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is what? 42. And it goes like that. So we can continue to have the multiples. But now for us to get these 2 values that we are looking for, which is x and y, then we start comparing we can compare the multiples of the value that we have here. So we compare pairs of this. So we can have 12 and 18. We find the LCM and the ACM. So if the LCM is 90 and the ACM is 6, then we are right. And you look again, we can look for 18 and 24, 24 and 30, 30 and 36, 36 and 42. So by the time you look at all of this, you find their LCM and ACM. So if their values are, the LCM is 90 and the ACM is 6, then those are the 2 values that we are looking for. So after doing that, let's try and see the ACF of 30 and the LCM of 18 and 30. So let's start with the LCM, which is the A part. So let's look at it. I want to give us another method there. So let's have 18 here and let's have 30. Let's look at the LCM. Now, if you want to do this, what you are going to be doing here is this. You look at the common values, which is common numbers that can go in 18 that can divide 30 at the same time without remainder. So I think 2 can divide 18, 2 can divide 30 without remainder. So let's start with 2. 2 can go in 19 how many times? That is 9 without remainder. 2 can go in 30 how many times? That's 15. Now, if you look at this, 2 cannot go in 9, 2 cannot go in 15, right? So we have to look for another values that can go together. So let's look at 3. 3 can go here. How many times can 3 go here? 3 can go in a 9. We have 3 times. And 3 can go in 15. How many times? That is what? 5 times. Now, 3 can still go in 3, right? But cannot go in 5. So let's divide through by 3 and let's say, so let's have 3. 3 can go in 3, 1. But we still have 5 here because it cannot go in 5. Now, 5 can go in what? 5 can go in 5. So we have 5 here left. 5 in 5 will give us what? 1. So for us to get the LCM, what we need to do is what? Multiply 2 times 3 times 3 times 5. So by the time you have that, 2 multiplied by 3, multiplied by 3, multiplied by 5. What is that? That is 90. So you see now that we have the LCM to be what? To be 90. Now let's try again and let's see if the ACF is going to give us 6 as the question implies. So let's look at the ACF, which is 18 and 30. Now for this one, what you just need to do is you find the common factors as well that goes in 18 and 30 and cannot without remainder. So let's look at it. 2 can go in 18, that is 9. 2 can go in 30, that's 15. If you go again, 3 can go in 9, how many times 3? 3 can go in 15, how many times? That is 5. 3 times 5 will give us what? 15. Now, if you look at this, 3 and 5, there's nothing again that is common to both of them. So since we are talking about highest common factor, so we stop at this because we don't have any other value that can go in 3 and 5 together. So the ACF of 18 and 30 will be what? 2 multiplied by 3. 2 multiplied by 3 is what? 6. So that implies that the two values that we are actually looking for is what? 18 and 30. So since it actually give us the solution to the problem we have, LCM is 90 and our ACF is 6. So the two values that we are looking for here is what? 18 and 30. So we can now say that x should be what? 18 because x is smaller, while our y should be what? 30. This takes us to the end of our class. We want you to subscribe to our channel for the full interactive content of this class. Our channel is www.edubbey.com. Thanks for listening.